This is part 5 of the Craftsman King Seeley 100 Drill Press Rebuild series. If you haven't seen part 4, click the link at the top of the screen. In this video, we're going to be making some modifications and do a little bit of fabrication. Hello everyone, I'm Jeff and welcome to my shop. We got a lot to cover, so let's get to it. First thing we're going to be doing is removing the motor data panel from the stator band. And this stator band, although it doesn't look great right now, is actually in pretty good condition. Normally I would just go ahead and fabricate a stator band, but I think I can clean this up enough that it's going to look good enough for this drill press. So if you want to know how I fabricate them, you can check out video 11 of the 150 series. I'll put a link at the top of the screen. But yeah, I think this one's going to clean up just fine. So once we've removed those rivets, we've got the tag off of there. We'll clean that up by hand, and we're going to soak that stator band. Next, the motor itself did not have a terminal cover, so I'm just going to fabricate one, and I'm just using some tracing paper here and a Sharpie, and we're just going to trace out the rough outline of the cover itself. And then we're going to transfer that over to a piece of 16 gauge steel. So once we've got it all traced out, we can go ahead and cut it out. And then transferring it over to the steel. And then we'll cut out the steel on my metal cutting bandsaw. Then we'll refine that with the belt sander. And test fit it, and there's a little area there that needs to hit the sander again, so I'll mark that and do that. Once we've got that done, then we're going to flip it over, and I'm just going to put a piece of tape on the back side down the center. And this piece of tape is going to get marked with where we need to drill holes for the 2 mounting screws. So now we'll mount it right side up and then tape it down so it doesn't move. And then I've got a long punch on the table there, and that punch is just smaller than the threads in the holes that the screws go in, so I can drop it in there and tap it with the hammer, and it's going to make an impression on the piece of tape that's on the bottom side. Now we can remove the cover. So next we'll go ahead and mark each one of those center points so the drill bit doesn't walk all over. And then we're just drilling it out. And then we'll chamfer those holes or deburr them with a deburring tool. Then we'll test fit it, make sure the holes line up. We're good to go. Next, I need to fabricate a lock screw for the pinion. And the actual OEM pinion lock screw has a dog point on it. So I've got a screw that's roughly, it's the same thread and it's almost the same length. It's a little longer than it needs to be. So I've just chucked it in my lathe and I'm going to turn down the end of it to put a dog point on there. And then all I need to do is face the end of that screw and make sure it's the right length and we'll be good to go. So there it is, and there's an OEM one. So you can see, yep. Next, the big difference between a 100 and a 150 is that retaining ring. And I want to put that on my 100, so I've chucked my quill into my lathe and I've already measured everything out. I just need to go ahead and mill in that channel that the retaining ring rides in. Now I'm using a cutoff tool here, so it's going to be a little bit wider of a gap than it needs to be. It's probably about a 1/16 of an inch wider than it needs to be, but that's fine. As long as we've got the right depth, everything should be a-okay. And that should be it. We'll just check it again. And we're golden. So we'll pull that out of the lathe and then we'll attempt to mount a retaining ring on there and then see if all this worked out. And I've got a video all about the retaining ring and why it's kind of important. I'll put a link to that at the top of the screen. But your 100s didn't have them, or at least most of them didn't. That was one of the big changes between a 100 and a 150. So this is a retaining ring that I got from McMaster Car. If you decide to do something like this, just post a message in the comments or something and I can put the part number in there for the retaining ring if you need it. Once I've got those vice grips set where they're not going to start turning on me, we can go ahead and mount that retaining ring like so. I probably could have sanded down that cutoff tool to make it thinner, but It's good enough for me, so it's not going to go anywhere. And then we'll just test fit it to make sure it's stopping the quill. Bingo. So next, the one part that I could not find a replacement for on eBay is the spring tension knob. Like, I could find a couple out there, but they didn't look any better than this one. So this thing used to be chrome at one time, and they painted over it, and there's like no chrome left on it. So we're going to polish this sucker, and I'm going to show you how you take something like this and make it look like chrome. So I'm starting with 100 grit sandpaper here, and I'm going to go 100, 120, 180, and 220. And then we're going to wet sand, and we're going to go 320, 400, 600, 800, and 1000. And when you're wet sanding, be sure to rinse the item off between each grit. And then we're going to apply Meguiar's mag and aluminum polish. Now you see how satin that finish on that knob looks right now. But once we buff that polish off, look at that. Stuff is magic, I tell you. So of course this is bare metal, so we're just going to coat it with penetrating oil, and it should be just fine. But now it looks almost like chrome. All right, so this is going to be a drill press for me, and I only do this on drill presses that I'm keeping. I make a power panel that drops inside the head casting, and it mounts a light bulb. The motor will plug into it, and then I drill a hole in the side of the head and put a switch. So I've got a little cardboard cutout of this power panel that I've used over the years. So I'm transferring that onto that 16 gauge steel. And then we're cutting out that pattern. And then we're just refining that shape with the belt sander. And using a sanding drum. And then we're going to mark it up for that receptacle you can see sitting on the table, and the power cord. So this will get a 9-foot power cord coming out of it. I'm just using a spring-loaded punch to mark where I've got to drill. And then the motor will only have like a 3-foot, maybe a 2-foot power cord on it. Kind of like how the Emerson Gen 3s and Gen 4s are. So here we're just drilling out the holes. For the rectangle that the receptacle goes in, I'm just going to drill out all 4 corners of it. And then the power cord hole. And then I'm just going to use a Fordham, but you could use a Dremel with a cutoff wheel to cut out the rectangle. And then we're just going to refine that hole and make sure that it's square and the right size for the receptacle. We'll test fit the receptacle. And then we'll test fit the grommet for the power cord. And then we need to bend this at a 90-degree angle. So we'll just put it in the vise, start hitting it with the mallet. Then we'll test fit it. Next, we're going to go ahead and drill the 2 holes that it will be mounted into the head casting with. Then we place the power panel back in the head casting and we drill through those holes and into the head casting for the mounting screws. Next, I'm drilling out a hole on the side of the head casting. This is where the power switch is going to go. And then we can tap those holes. So I'm going to use a 12-24 by 3/4 of an inch slotted screws to mount this in here. And the other side. I'm sure somebody could come up with another way where you don't have to tap and drill into your head, but this is the way I do it. And we'll test mount those screws. And then just test fit the bracket again. All right, so the previous owner had tapped the other side and used a larger screw on the other side for the motor mount lock screw. So I'm doing the same thing on this side so that they're the same on both sides. That way I don't need to use 2 different wrenches to adjust the motor, and my OCD does not cause me to start throwing stuff around the shop. Drilled it out, tapped it out. And then just test fit the bolt. And we're golden. So that's going to wrap up this video. I hope you enjoyed it. If you have any questions, please post them in the comment section. I think we got a whole lot of cleaning and polishing to do next. So until then, as always, I appreciate the support, and I will see you next time.